Welcome back to our automation series. So if you just need a personal script, you're good to go. You can now write whatever code you want. You can go to any website, you can get data, or you can click through buttons. Here's two ideas. You could write a script that takes in a string and posts to both X and threads at the same time. Or you could write a script that automates an annoying task in your life, like something that logs your 40 hours a week. For my business, that takes like 7 clicks. It'd be really nice to just click one button, have it launch, and then do it for me. So the rest of this series is going to be dedicated to the next level, which is automated testing. Essentially, you build tests that run using Selenium and Java. These test the functionality of a website and confirm that it's working. The tests would run constantly during a development cycle. So why would you do automated testing? Well, because developers break stuff constantly. You'd be surprised. Code is very brittle, and you want to have confidence that when you update part of your system, it didn't break the rest of the system, which actually happens all the time. Some businesses solve this with manual testing. They'll hire 100 guys in third world countries to click all the buttons every night. With automated testing, you can write the code once, and then the test can execute an infinite number of times in a reliable way. You don't have to train people, and you don't have to rely on the employees following the protocol. So to run our automated tests, we're going to use Cucumber. Here's a quick example. Our test is going to look like this, and it's based off the code we already wrote. So at the top, you have a feature. Our feature is autocomplete results from Google. The scenario is autocomplete results from Google as well. And then it's formatted in given, when, then. So given is our prerequisite state. Given the user navigates to Google. When the user searches for hello world, then the following search results should be displayed. Underneath the hood, these map to actual Java code, the same Java code that we just wrote, although we will make some updates. Okay, there's a lot to learn with Cucumber, but instead of getting into all of the jargon right now, let's just build a test really quickly, and then we'll come back in the next video and really get into the details on how this works. Okay, let's get started. First up, go to your POM file, and you need to paste these 3 dependencies: cucumber-java, cucumber-junit, and junit, and then do a Maven refresh. Then go to Settings, go to your plugins, and search for Cucumber. We're going to be using Cucumber for Java. Next up, look in your folder structure, and you want to find the test folder. Underneath the test folder, there's a Java folder. So let's create a new package called Resources. Underneath Resources, create another package called Features. Underneath the Java folder, create a new package called Step Definitions. And lastly, also underneath the Java folder, create a new package called Runners. You must do this exactly as I say, otherwise it won't work. Next up, let's create our first feature file. So within Features, we're going to create a new file, autocomplete results, and then it needs to end in .feature. You know you did it right if you see this little cucumber slice icon. Next, we're going to write feature with a colon, autocomplete results from Google. And if it highlights in orange, you know you did it right. Then underneath that, we're going to say scenario, also with a colon. And the scenario name is going to be the same in this case as the feature name. All tests are in the format of given, when, then. So let's go ahead and write out our test. Given, user navigates to Google. When, user searches for hello world in double quotations. Then the following search results should be displayed. Underneath the last one, we're going to use some pipes to be able to pass in more data. So the first row will be search results, the next will be programming, and the last one will be learn to code. This is technically a data table, but we'll get to that in a second. Going into our step definitions package, let's create a new Java class, autocomplete Google. This is where the actual code lives. So we use the annotation @given, @when, and @then. And then import each one. So these are going to map directly to our test. So I'm going to copy this exact string and paste it in double quotes over in the given statement. Underneath this is a plain old Java method, public void, give it a nice name, and this is where your code would go. Notice if you did it correctly, it no longer highlights it in yellow. And if you hover while holding the command key, it underlines in blue, which tells you exactly what it's mapped to. Let's do the same thing here. However, for this one, we are passing in a string. So let's delete this and instead use squirrely braces and string. This will then be passed into the method. And of course, we did it correctly, so now the yellow highlight goes away, and if we control click, it brings us straight to the implementation. Let's go ahead and do the last one. Now what we did here is technically a data table. So Cucumber is smart enough to be able to read this data and pass it in that way. So in our method, we're going to pass in data table, and we'll call it data table. And make sure you do the correct import. This is a very simple data table. It's just a list of strings. So I'm going to say list of strings expected is equal to data table as list. However, there is one problem. If you look at our feature file, there are 3 things in the list: search results, programming, and learn to code. So this is the list that'll come through. We actually don't want this. We want to exclude the first one of search results. We're just providing more context as to what this is supposed to be. So we can use the Java Streams API to simply skip the first one. And now we will only be validating the last 2. Okay, so let's go back to the code that we wrote in the last video. And we're really close. We just need to organize it in a slightly better way. First off, we'll add a WebDriver, and we'll instantiate it in the first method. WebDriver is equal to new Chrome driver. And FYI, this is not the most elegant way to do this. We're trying to just get to the end right now. We're going to come back in the next video and abstract this WebDriver in a much better way. For now, just hard code it. Okay, let's extract out our navigate to Google code into its own method. And this time we will need to pass in a WebDriver. Same thing, just hard code it for now. We'll clean it up later. I'm going to go ahead and add a default constructor for the crawler. And now I can call my method. Okay, the first step definition is now complete. Next up is enter search term, and we already have a great method for this, so let's just convert it to public, and we'll also pass in our WebDriver and use that one in the method. And we'll go ahead and call new crawler.enter search term, where we pass in the search term that we got from the statement and the WebDriver. Lastly, we have this print autocomplete results. We're going to modify this so that it returns a list of strings of the autocompleted results. So we're going to delete the print line statements. And again, we're going to pass in a WebDriver for now. And then we're going to stream.map item.getText. Make it public and rename your method to something sensible. Get autocomplete results. Let's go ahead and call it. So a list of string actual is equal to new crawler.get autocomplete results, where we pass in the WebDriver. Before we get the autocomplete results, we do want to make sure that the elements are visible. So let's just call our wait until invisible private method, and we'll change it to also take in the WebDriver. Make sure to call WebDriver.quit so at the end of your test, it goes ahead and closes the Chrome browser. And lastly, we're going to need an assertion statement to make sure that these 2 lists are equal. So assert.assert equals, we have a message that prints if this assertion fails, and we pass in the expected and the actual. Okay, that's all we have for coding. Now we need to set up our test runner. In our runners folder that we previously created, we're going to do new Java class. I'm going to call it test runner. Annotate it with exactly this. So we have @runWith cucumber.class, and then we have some Cucumber options. The features points to the folder where your feature files live. So source, test, resources, features. The glue points to the step definitions. In this case, we just said step definitions, so it'll be able to look and find that. And lastly, we have a plugin that'll give us a nice pretty report at the end. Okay, if you right click on this file and click run, then you'll see it start the execution. This will run all of the feature files in that folder. It launches the Chrome browser, it looks. Now if we go back to the terminal, we can see that this test failed. The lists are not equal. We were expecting 2 things, but it was actually a long list of other things. I expected this test to fail. And we also got the error message that we passed in. And if you notice, because this assertion failed, it stopped the execution. This WebDriver never quit. This Chrome instance is still running. So we'll need to figure out a way to abstract this WebDriver.quit so that it quits even if the test fails, but we'll do that in a future video. So I'm going to go ahead and quit the Chrome browser. Okay, that's all I have for you today. I wanted to just get us up and running as quickly as possible. In the next video, we're going to really sit down and explain, okay, what did we do? How did this work? What are the names of everything? And how do we abstract some of these things so that they fire automatically? And how do we not worry about passing WebDrivers around all of the time? Okay, I'll see you in the next video.